Alright, we have a new unit on probability. We're going to start with basic concepts of probability, and you'll see some terms to start us off. An event is a result or outcome of a procedure. A simple event can't be broken down further. Sample space is all the possible simple events. P stands for probability, and we'll use the letters of the alphabet to represent events. We have two ways to calculate the probability of an event, A. We have the approach where you take the number of times that A occurred out of the number of times you repeated the procedure. Or we have what's called the classical approach, which is the number of ways that A can occur divided by the number of possible outcomes. That's the approach that we'll use most of the time. It does require that all events are equally likely, and we'll talk about that when we get to some examples. The law of large numbers states the more times you repeat a procedure, the closer the observed probability will be to the actual probability. An example of that is if you were flipping a coin, you would get, if you just flipped a coin once, the probability of heads is 0.5, and the probability of tails is 0.5. If you flip a coin 100 times, you would expect that 50 of them would be heads and 50 would be tails. But it may not turn out exactly like that. You may get 48 of one and 52 of the other. But the more times you do it, if you did it 1,000 times or 10,000 times, your observed probability should be close to half and half, which is the actual probability for heads and tails. Okay, some basic probability values. If an event is impossible, its probability equals 0. If an event has to happen, if it's certain, probability equals 1. But any other event will be between 0 and 1. So you can report probabilities as fractions or decimals between 0 and 1. Sometimes it's just easier to leave probabilities in fractions, which is what I'll show in the examples coming up. One trick to keep in mind is something called a complementary event, which is the probability that the event A will not occur. And we get that, the probability of A, the complement of A, you can see there's a line drawn above the A, is 1 minus the probability of A. So, for example, the probability of heads, if you're flipping a coin, is 0.5. The probability of not heads is 1 minus 0.5, which is 0.5. So that seems like a simple example, and it is, but we'll get to some a little bit more complicated ones later, where the complementary event rule will come in handy. Okay, so here's our examples. The first one, we're going to flip one coin at a time, and flip the coin just once. So the first thing I want to do is write our sample space. The sample space is in brackets, and we're going to write all the possible outcomes for flipping a coin one time. So if we flipped a coin one time, we could get heads. I'm going to H for heads. The other outcome is we could get tails. T for tails. Those are the only two outcomes, so that's our entire sample space. Now we can calculate probabilities. So the probability of heads, there's one way to get heads out of two possible outcomes. So the probability of heads would be 1 out of 2. The probability of tails, there's also only one way to get tails out of two possible outcomes, so that's also 1/2. So again, that's an easy one. If you were to flip a coin 3 times, our sample space is going to get a little bit more complicated. You could flip a coin the first time and get heads, the second time and get heads, and the third time and get heads. So that's one outcome. You could flip a coin and get heads and then tails. You could flip a coin 3 times and get heads, tails, heads. You could get tails, heads, heads. We could get any possibilities with 2 tails and 1 head. And there's the possibility of getting tails all 3 times. So there's our sample space. So let's look at the probability of getting heads 3 times in a row when you're flipping a coin just 3 times. The probability of getting all 3 heads, there's one way that can happen out of 8 possible outcomes in our sample space. Another way to calculate that, if you didn't want to write out the entire sample space, we know the probability of 1 head is half. So the probability of 3 heads, and we do something called the multiplication rule, where you just multiply each event's probability, and you get half times half times half is 1/8. So the probability is 1/8 whether you do it by looking at the entire sample space and finding that there's 8 possible ways to flip a coin 3 times, and that getting all 3 heads is one way out of those 8. Or you could take the probability of each flip and multiply them together for how many flips you have. So we could also look at the probability of 2 tails and 1 head. And we can say in any order. So let's look for 2 tails and 1 head. We have 2 tails and a head here. And here's another one. And here's another one. So there's 3 ways that you can get 2 tails and 1 head out of 8 possible outcomes. So the probability of getting 2 tails and a head is 3 out of 8. Alright, last example. If you're going to select one physician from a group of 20 physicians, 18 of them happen to be female and 2 of them happen to be male. You can see I've written out the sample space already. So let's determine the probability of selecting a female. And there's 18 possible ways to select a female out of 20 possible outcomes. So we get a probability of 18 out of 20. We'll say the probability of choosing a male, there's 2 males in the group out of a total of 20 physicians. So again, those are a little bit easier as well because you're only selecting one thing, where in example 2 you were flipping a coin 3 times, so you had to look at the outcomes of 3 things in a row. So those are some basic concepts and basic examples of probability. We'll continue with the addition rule and some more examples coming up in the next video.